Hello and welcome back. If you're here, maybe you had a long day. Maybe your mind is still spinning with all the things you need to do tomorrow, or all the things you didn't quite finish today. That's okay. You're here now, and for the next little while, we're going to do something quiet together. We're going to explore something you carry with you everywhere you go. Something so familiar, you almost never think about it, your own body. Tonight, we'll wander through 100 facts about the human body. Not in a textbook way, but in a way that invites wonder. We'll look at the strange architecture of your bones, the electrical storms in your brain, the ancient rhythms that still pulse through you. Some of these facts might surprise you. Others might feel like meeting an old friend you'd forgotten about. All of them are true, as far as we know, which is to say, they're our best understanding of the mystery that is you. Before we begin, if you enjoy these journeys into the quieter corners of science, consider subscribing. It helps this channel grow, and it means you'll have more nights like this one waiting for you. But no pressure. Whether you subscribe or not, you're welcome here. Now let's begin. Your body contains approximately 37.2 trillion cells. Let that number sit with you for a moment. 37.2 trillion. It's the kind of number that doesn't quite fit in the mind. The kind that makes you realize how strange it is that we use the word I as if we're a single thing. Each one of those cells is a living entity, breathing, consuming energy, communicating with its neighbors, dying and being replaced. They work in harmony, mostly without your conscious input, orchestrating everything from the beating of your heart to the thoughts you're having right now. To put it in perspective, that's roughly 5,000 times more cells than there are stars in the Milky Way galaxy. When you look up at the night sky and feel overwhelmed by the vastness of space, remember, you contain an even greater multitude. You are, in a very real sense, a universe unto yourself. Each cell is a world. And somehow, impossibly, all these worlds coordinate to create the experience of being you. It's enough to make you wonder what you even means, whether you're the conductor of this symphony or just another instrument playing along. And speaking of that symphony, here's something even stranger. Your body replaces about 330 billion of those cells every single day. While you're reading this, while you're drifting towards sleep, while you're dreaming, your body is quietly rebuilding itself. Think about that. 330 billion cells. Gone, replaced, renewed. It happens so seamlessly you never notice. There's no fanfare, no sensation of transformation. Just a constant, gentle renovation happening beneath your skin. In essence, you're becoming a slightly different physical being with each passing week. The you of a month ago shared your memories, your name, your sense of self. But on a cellular level, much of that person is gone now, replaced. Which raises a beautiful question. If the material of your body is constantly changing, what is it that remains constant? What is the thread that connects the you of yesterday to the you of tomorrow? Maybe it's not the cells themselves, but the pattern they form, the way they organize and reorganize into the shape of your life. You're not a thing so much as a process, a verb disguised as a noun. Let's talk about your bones for a moment. When you think of bones, you might imagine something hard and dead, like the skeleton hanging in a science classroom. But your bones are far from dead. They're not even solid. In fact, Your bones are about 60 to 70% mineral and 30 to 40% organic material, with a spongy interior that's actively producing blood cells every moment of your life. This hollow architecture, this space inside the solid, is what makes bones both strong and light. It's elegant engineering, the kind that makes you appreciate the trial and error of evolution. Solid bones would be too heavy to carry around. Hollow tubes would be too fragile. So your skeleton found a middle path, a compromise between strength and weight that lets you move through the world without collapsing or floating away. And inside that compromise, inside the honeycomb spaces of your bones, your body is manufacturing the very blood that keeps you alive. Your bones aren't scaffolding. They're factories, quiet and hidden, working around the clock. Your heart beats approximately 100,000 times per day, 100,000 tiny compressions, each one sending blood rushing through miles and miles of vessels, feeding every corner of your body with oxygen and nutrients. Over the course of a single day, your heart pumps about 2,000 gallons of blood. Over a lifetime, that's enough to fill more than 3 Olympic-sized swimming pools. And yet, you almost never think about it. Your heart doesn't ask for your attention. It doesn't wait for permission. It just keeps going, beat after beat after beat, from the moment you were born until the moment you die. It's one of the most reliable things about you, this muscle that never rests, never takes a break, never stops to ask if you're grateful. Maybe you should be. Maybe tonight, as you're falling asleep, you could take a moment to notice it. The quiet, rhythmic proof that you're alive. The drum that plays the soundtrack of your existence. Here's something your stomach does that you've probably never thought about. Every 2 weeks, it produces a completely new layer of mucus to protect itself. Without this barrier, your stomach acid, which is strong enough to dissolve metal, would digest the stomach wall itself in a matter of minutes. Think about that. Your body is producing a substance so corrosive that it could eat through your own tissue, and the only thing standing between you and self-destruction is a thin layer of mucus that needs to be constantly refreshed. It's a precarious balance, this life we live. So many things could go wrong, so many systems that need to work perfectly in concert to keep us intact. And yet, most of the time, they do. Your stomach doesn't accidentally digest itself. Your heart doesn't forget to beat. Your lungs don't forget to breathe, even when you're not thinking about them. There's something almost miraculous about how well maintained you are, how many invisible processes are working right now to keep you whole. You are a walking miracle of maintenance, held together by systems you'll never consciously control. Your eyes can distinguish approximately 10 million different colors, 10 million variations in the wavelengths of light, each one creating a slightly different experience of seeing. Some colors you have names for: red, blue, chartreuse, vermilion, but most of them you don't. Most of them exist in your perception without ever being captured in language. You can see them, but you can't quite describe them. They live in the gap between experience and words. It makes you wonder how much of your life is like that, perceived but not named, felt but not spoken. Your eyes are taking in this incredible spectrum of information, more colors than you could ever catalog, and your brain is weaving them into the seamless experience of sight. You're not seeing pixels or wavelengths. You're seeing a world rich and textured and whole. And somehow, the fact that you lack the vocabulary to name even a fraction of what you can perceive doesn't diminish the experience. Maybe some things are better left unnamed, experienced directly, without the filter of language. Here's a strange inventory of what you're made of. Your body contains enough iron to make a 3-inch nail, enough sulfur to kill all the fleas on a dog, and enough carbon to make 900 pencils. We are, quite literally, made of the same materials as the world around us. The iron in your blood is the same iron that rusts on old cars. The carbon in your cells is the same carbon in diamonds, in coal, in the graphite of pencil lead. There's no special life substance that separates you from rocks and trees and rain. You're made of ordinary matter, arranged in an extraordinary way. It's a humbling thought, maybe, that you're built from such common ingredients. But it's also kind of beautiful. It means you belong here, on this planet, in this universe. You're not separate from the world. You're continuous with it. The boundary between you and not you is more permeable than it seems. You breathe in the air, and it becomes you. You eat food, and it becomes you. You're constantly exchanging material with your environment, a swirl of atoms that temporarily forms the pattern of your body before dispersing again. The fastest nerve impulses in your body travel at about 250 miles per hour. That's the speed at which information races from your brain to your fingertips, from your spinal cord to your toes. It sounds fast, and it is, but it's not instantaneous. There's a tiny delay, a fraction of a second gap between when something happens and when you consciously register it. When you touch something hot and pull your hand away, the pain arrives after the reflex. Your body reacts before you fully understand what's happening. This is why you can react to things almost as quickly as you perceive them. Your nervous system is a high-speed network, transmitting signals at velocities that make modern internet connections seem sluggish by comparison. And yet, even at 250 miles per hour, there's lag. You're always living slightly in the past, processing information that's already happened. The now you experience is actually a moment ago, reconstructed by your brain from signals that took time to arrive. In a way, you're never quite caught up to the present. You're always chasing it, millisecond by millisecond. Your lungs contain about 1,500 miles of airways and over 300 million tiny air sacs, called alveoli. If you could somehow unfold your lungs and lay them flat, they would cover an area roughly the size of a tennis court. All of that surface area is packed inside your chest, folded and compressed into a space you could wrap your arms around. It's an astonishing feat of biological origami. Every breath you take, and you take about 20,000 of them each day, sends air rushing through this vast internal landscape. The oxygen diffuses across those hundreds of millions of alveoli into your bloodstream, and carbon dioxide makes the return journey, expelled into the air with each exhale. It's a transaction you never think about, an exchange happening constantly at the boundary between inside and outside. You're not a closed system. You're porous, breathing in the world and breathing out a part of yourself, over and over, in a rhythm that started the moment you were born and will continue until it stops. The human brain uses about 20% of your body's total oxygen and energy, despite being only 2% of your body weight. Let that ratio sink in for a moment. This organ, small enough to hold in your hands, consumes a fifth of everything you eat and breathe. Thinking, it turns out, is one of the most expensive biological activities you can perform. More expensive than running, than digesting food, than healing a wound. Your brain is an energy hog, demanding constant fuel to keep the lights on. And what is it doing with all that energy? It's maintaining your consciousness, processing sensory information, storing and retrieving memories, regulating your body's functions, generating emotions, constructing your sense of self. It's doing all of this simultaneously, right now, even as you're winding down for sleep. Even when you're dreaming, your brain is burning through calories, weaving narratives from fragments of memory and sensation. The cost of being you, of having a rich inner life, of experiencing the world as a conscious being, is remarkably high, but somehow the investment seems worth it. Every human being begins as a single cell, a fertilized egg about the size of a grain of sand. It's almost impossible to imagine, isn't it, that something so small, so simple, could contain all the instructions needed to build you. But it does. Inside that microscopic sphere is a complete blueprint, a recipe written in DNA that will unfold over months and years into eyes and hands and a beating heart. From that one cell, roughly 1 trillion divisions occur to create a full human body. 1 trillion. Each division perfectly orchestrated, each new cell knowing somehow where it belongs and what it's supposed to become. Some cells will form your bones. Others will become neurons, carrying electrical signals through your brain. Still others will line your stomach or form the lens of your eye, or become the muscle tissue of your heart. They all start the same, but they diverge, specializing, finding their purpose in the grand architecture of you. It's hard not to feel a sense of awe at this process, at the way complexity emerges from simplicity, at the way a single point of beginning becomes an entire person. In the womb, babies grow a type of body hair called lanugo, fine whisker-like strands that cover almost the entire body. For most babies, this hair falls out before birth, absorbed back into the body or shed into the amniotic fluid. It's an evolutionary remnant, a ghost from our distant past when our ancestors were covered in fur. Your body still remembers how to grow a full coat of hair, even though you don't need it anymore. Evolution doesn't erase features cleanly. It layers new adaptations over old ones, leaving traces of what came before. Lanugo is one of those traces, a brief return to an earlier version of humanity that plays out in the privacy of the womb. By the time you're born, it's usually gone, but the fact that it appears at all is a reminder that you carry history in your cells. You're not just a product of your own lifetime, but of millions of years of ancestors, each one shaped by different needs, different environments. In a sense, you're a living museum, displaying exhibits from eras long past. Speaking of evolutionary echoes, here's another one. A human embryo briefly has gill-like structures and a tail during early development. These features don't last long. The gill-like structures transform into parts of your face and neck, and the tail typically retracts and becomes your tailbone. But for a brief window of time, you looked like something that could have lived in water, something that had a tail to balance with. You carried the shapes of your evolutionary past in your own developing body. It's as if development is a time-lapse of evolution itself, a fast-forward through millions of years of history. You start as a single cell, like the first life forms. You develop structures that resemble fish, then amphibians, then mammals. By the time you're born, you're recognizably human, but you've passed through all these earlier forms on the way. Your body remembers the journey, even if you don't. It's written into the way you grow, the sequence of structures that appear and disappear, the shapes you briefly take before becoming yourself. By the time you're born, you have all the brain cells you'll ever have, about 86 billion neurons. That number might sound limiting at first, as if you're working with a fixed deck of cards for the rest of your life. But here's the thing. What changes throughout your life isn't the number of neurons, but how they connect to each other. Each neuron can form thousands of connections with other neurons, creating a network of staggering complexity. These connections, called synapses, are where learning happens, where memories form, where your personality takes shape. Every experience you have, every thought you think, every skill you learn strengthens some connections and weakens others. Your brain is constantly rewiring itself, pruning unused pathways and reinforcing the ones you travel frequently. So while you start with a fixed number of neurons, the brain you have now is vastly different from the one you were born with. It's been shaped by your life, sculpted by experience, customized to be uniquely yours. You're not stuck with the brain you were given. You're building it every day with every choice you make. Here's something that might surprise you. Babies have about 300 bones, but adults have only 206. Bones don't disappear exactly. They fuse together as you grow. Many of the separate bones in a baby's skull, for instance, gradually merge into the solid structure of an adult skull. The same thing happens throughout the skeleton. Bones that started out separate become single, stronger units. This fusion gives you strength and structure as you need to support your own weight and move through the world. A baby's body is softer, more flexible, designed to survive the journey through the birth canal and to grow rapidly in the first years of life. But as you age, your body trades some of that flexibility for stability. Your bones harden, connect, become the framework that will carry you through decades of life. It's a one-way transformation. You can't unfuse bones, can't return to that earlier flexibility. Growing up in this sense is quite literal, a hardening, a solidifying, a becoming of something more permanent. The first sense to develop in the womb is touch, appearing around 8 weeks after conception. Long before a fetus can hear or see, it can feel. By 18 weeks, hearing develops, and babies can hear their mother's heartbeat, the rumble of her voice, the muffled sounds of the world outside. They're listening, learning the rhythms of life before they're even born. This means you spent months in the dark, floating in warm fluid, listening to the percussion of your mother's heart. That sound was the soundtrack of your earliest existence, a rhythm you knew before you knew anything else. Some researchers believe this is why steady heartbeat sounds are so soothing, why babies calm when held against a chest, why you might find comfort in rhythmic sounds even now. You're remembering something perhaps, even if you don't have conscious access to the memory. Your body remembers what it felt like to be safe, surrounded, held in a space where every need was met, and every sound was a reminder that you weren't alone. Humans lost their tails about 25 million years ago, and scientists discovered the exact reason why in 2024. A specific DNA mutation occurred in our primate ancestors, a tiny change in the genetic code that prevented tails from forming. It's remarkable, isn't it, that they could pinpoint the moment, or at least the mutation, when this happened. One small change in one gene, and suddenly our ancestors were tailless, beginning the long journey toward becoming human. Evolution often works through these kinds of accidents, these random mutations that turn out to be advantageous or at least not harmful enough to be selected against. Losing our tails may have been beneficial as our ancestors began spending more time upright, walking on two legs. Or maybe it was just neutral, a change that stuck around because it didn't matter enough to be eliminated. Either way, you're tailless now, carrying in your body the legacy of that ancient mutation. Your tailbone is what remains, a small cluster of fused vertebrae that hints at what used to be there, a reminder that you're descended from creatures quite different from yourself. Your fingerprints formed about 3 months before you were born, and they will remain unchanged your entire life. The whorls and loops and arches on your fingertips are as much a part of you as your DNA, unique markers that distinguish you from every other person who has ever lived. Not even identical twins who share the same genetic code have the same fingerprints. The patterns form through a combination of genetic factors and random events in the womb, the way the fetus moves, the density of the amniotic fluid, tiny variations in pressure and growth rate. It's a beautiful mix of nature and chance, of determinism and randomness. Your fingerprints are yours alone, a signature written on your body before you could even think or choose or decide who you wanted to be. In a way, they're proof of your individuality, evidence that you're not just a product of your genes, but of the specific, unrepeatable circumstances of your development. You are singular. You always have been. Humans are born with the ability to hold their breath underwater instinctively, a reflex called the bradycardic response. If you submerge a baby up to 6 months old, they'll automatically hold their breath, and their heart rate will slow down to conserve oxygen. It's an ancient survival mechanism, possibly left over from our distant, evolutionary past, or maybe just a safety feature that helps babies survive the sudden, wet transition of birth. This reflex fades as you grow older, though. By the time you're an adult, you have to consciously decide to hold your breath. You lose that automatic response, that instinctive knowing that protected you when you were most vulnerable. Maybe that's true of a lot of things we're born knowing. The body has its own wisdom, especially early in life, but as consciousness develops, as you learn to think and choose and override your instincts, some of that ancient knowledge fades. You gain control, but you also lose something, a connection to the deep, wordless intelligence that kept your ancestors alive for millions of years. The human appendix was long thought to be useless, a vestigial organ left over from a time when our ancestors needed help digesting plant matter. But recent research suggests it may actually serve an important function. It stores beneficial gut bacteria as a kind of safe house during illness. When a disease wipes out the bacteria in your intestines, the appendix can help repopulate your gut with the microbes you need to stay healthy. Evolution rarely keeps truly useless features. If something persists across millions of years and countless generations, There's usually a reason, even if we don't understand it yet. The appendix might have seemed pointless because we were looking at it wrong, asking the wrong questions, assuming that if we didn't understand its purpose, it must not have one. But nature is patient. It doesn't explain itself. It just keeps doing what works, whether we notice or not. And sometimes, if we're lucky, we eventually figure out what was there all along, hidden in plain sight, waiting for us to catch up. Your body temperature naturally drops in the late afternoon, which is why many people feel sleepy around 2 or 3 p.m. You've probably experienced it, that post-lunch drowsiness, the way your eyelids get heavy even if you slept well the night before. You might have blamed it on the food, on the carbohydrates making you sluggish, but really, it's just your body following an ancient rhythm. This is your circadian clock at work, a dip in temperature that signals to your system that rest might be a good idea. This isn't just the result of what you ate for lunch. It's an evolutionary pattern, a biological rhythm that exists whether you're in an office or a forest, whether you've eaten or not. Your ancestors might have used this time to rest in the shade during the hottest part of the day, conserving energy when the sun was at its peak. You still carry that rhythm even if you're expected to push through it, to stay alert and productive all afternoon. But your body remembers. It's trying to tell you something, even if modern life doesn't always let you listen. You're about 1 centimeter taller in the morning than you are at night. It's a small difference, easy to miss, but it's real. Throughout the day, gravity compresses the cartilage in your spine, squeezing the fluid out of the discs between your vertebrae. By evening, you've literally been pressed down, shortened by the constant weight of standing and sitting and moving through the world. But sleep gives your spine time to decompress, to expand back to its full length. It's a reminder that you're not as solid as you might think. You're flexible, compressible, responsive to forces you barely notice. Gravity is always pulling on you, always pressing you down, and your body is always resisting, always pushing back. The height you are right now isn't fixed. It's a negotiation between your body and the world, a balance that shifts throughout the day. When you lie down tonight, your spine will slowly stretch back out, reclaiming that lost centimeter. By morning, you'll be taller again, at least for a little while, before gravity starts its work once more. Your stomach acid has a pH between 1.5 and 3.5, which makes it strong enough to dissolve metal. If you dropped a piece of zinc or aluminum into your stomach, it would eventually break down, eaten away by the acid that's sloshing around in there right now. And yet your stomach remains perfectly intact. It doesn't digest itself, doesn't corrode from the inside out, because of that thin layer of mucus we talked about earlier. The mucus lining is one of nature's most remarkable protective barriers, a shield that stands between you and self-destruction. Think about how precarious that is. You're producing a substance corrosive enough to break down metal, to dissolve the proteins and fats and carbohydrates in your food, and you're keeping it inside your body, inches away from vital organs. One small failure in that mucus layer, and you'd have a problem, but it works. Day after day, year after year, your stomach handles this dangerous substance without incident. It's a system that seems almost reckless in its design, and yet it's been working for millions of years. Sometimes the most fragile seeming solutions are the most reliable. Humans shed about 30,000 to 40,000 dead skin cells every minute. That's millions of cells every hour, billions every day, all of them falling away from you like snow you never see. Much of the dust in your home is made up of these cells, tiny pieces of you and everyone else who lives there, accumulating on surfaces, floating in the air, settling into carpets and corners. In essence, every home is partly made of its inhabitants, a collection of discarded cells that tells the story of who lives there. You're constantly leaving traces of yourself behind, even when you're trying to be clean, even when you're sitting still. You can't help it. Shedding skin is how your body renews itself, how it gets rid of the old and damaged cells and makes room for new ones. But it also means you're never fully contained. You're always dispersing, always becoming part of your environment in ways you don't consciously control. The boundary between you and the world around you is more porous than you might think. You're not a sealed system. You're permeable, leaking, spreading out into the space you inhabit. Your nose can remember 50,000 different scents, and smell is the sense most closely linked to memory. A single whiff of something, coffee brewing, rain on pavement, your grandmother's perfume, can transport you decades into the past in an instant. The connection between smell and memory is direct, almost magical in how immediate it feels. You don't have to work to remember. The smell does it for you, pulling up images and feelings that you didn't even know you still had. This happens because the olfactory bulb, which processes smells, is closely connected to the hippocampus and amygdala, brain regions involved in memory and emotion. Smells bypass the usual processing routes that other senses take. They go straight to the parts of your brain that handle emotion and memory, which is why they can be so evocative, so powerful. A smell doesn't just remind you of something, it makes you feel like you're there again, like you've stepped backward through time. In a way, scents are time machines, small portals to moments you thought were lost. When you blush, the lining of your stomach blushes too. The blood vessels there respond to the same emotional triggers that make your face turn red. It's strange to think about, isn't it? That your embarrassment isn't just visible on your face, but is also happening inside you, in places you can't see. Your stomach is participating in your emotions, flushing with blood when you feel self-conscious or anxious or caught off guard. Your emotions don't just show on your face. They ripple through your entire body, affecting systems and organs you never consciously think about. When you're scared, your digestion slows down. When you're happy, your immune system functions better. When you're stressed, your muscles tense up, your heart rate increases, your breathing becomes shallow. You're not a brain piloting a body. You're a unified system where mind and body are so intertwined they can't really be separated. What you feel emotionally becomes what you feel physically, and vice versa. You are, entirely and completely, both at once. Goosebumps are a vestigial reflex from when our ancestors had more body hair. When you get cold or frightened, tiny muscles at the base of each hair follicle contract, making the hairs stand up. For our hairier ancestors, this would have trapped air close to the skin for insulation, or made them look larger and more intimidating to predators or rivals. But now, with our relatively hairless skin, goosebumps don't do much of anything. They're just a ghost of a response, your body running old software that doesn't quite work anymore. And yet, your body still performs this ancient defense, still tries to puff up your non-existent fur. It's a reminder that evolution is slow, that bodies change faster than the reflexes that control them. You're walking around with systems designed for a different version of humanity, one that lived in different conditions, faced different threats. Some of those systems are still useful. Others, like goosebumps, are just echoes. But they're your echoes, part of the long history written into your flesh and bones. Your ears and nose never stop growing throughout your entire life, though the growth is extremely slow. It's not that new cells are dividing rapidly, the way they do when you're young. It's more about gravity and the continuous growth of cartilage, the soft tissue that gives your ears and nose their shape. Over decades, they gradually get a bit longer, a bit larger, drooping slightly under their own weight. This is why elderly people often have noticeably larger ears and noses. It's not your imagination. They really are bigger than they used to be. Time leaves its mark on all of us, and for ears and noses, that mark is measured in millimeters of cartilage, in the slow, inevitable pull of gravity. It's a gentle reminder that nothing stays the same, that even the parts of you that seem stable are changing, just slowly enough that you don't notice from day to day. But the change is there, accumulating, writing the story of your aging into the very shape of your face. Hiccups are an evolutionary remnant, possibly inherited from amphibian ancestors that needed to coordinate breathing with both gills and lungs. When you hiccup, your diaphragm contracts involuntarily and your vocal cords snap shut, creating that distinctive hic sound. It's a glitch in your breathing pattern, a spasm that serves no obvious purpose in modern humans. But millions of years ago, for creatures transitioning between water and land, this kind of reflex might have helped them manage the complex task of breathing in two different ways. Your body occasionally runs software that's millions of years out of date. Hiccups, goosebumps, the startle reflex. These are all programs written for earlier versions of you, earlier species in your evolutionary lineage. They're not harmful, usually, just inconvenient or strange, but they're proof that you carry history in your body, that evolution doesn't wipe the slate clean with each new adaptation. It builds on what came before, layering new features over old ones, leaving traces of every ancestor you've ever had. You cannot tickle yourself. Go ahead, try it. It doesn't work, does it? That's because your brain predicts the sensation before you feel it and cancels it out. Ticklishness requires the element of surprise, the unpredictability of someone else's touch. When you're in control of the movement, when you know exactly where and when the touch is coming, your brain filters it out, decides it's not important information. This is part of how your brain manages the constant flood of sensory input it receives. If you felt every sensation with equal intensity, every brush of fabric against your skin, every movement of your own body, you'd be overwhelmed. So your brain learns to ignore predictable sensations, to focus on what's unexpected, what might be important or dangerous. The downside is that you lose some experiences. You can't surprise yourself. You can't tickle yourself into laughter. But the upside is that you can function, can move through the world without being paralyzed by sensation. It's a trade-off, like so many things about being human. Your tongue has between 2,000 and 8,000 taste buds, each one containing 50 to 100 taste receptor cells. These tiny sensors are scattered across your tongue, the roof of your mouth, your throat, detecting the chemicals in the food you eat and translating them into the experience of taste. Sweet, salty, sour, bitter, umami. These are the 5 basic categories your taste buds recognize, though the combinations and intensities create infinite variations. What's remarkable is that these cells are replaced every 10 to 14 days. Your sense of taste is constantly being refreshed, rebuilt from scratch on a schedule you never notice. The taste buds you have right now aren't the ones you had 2 weeks ago. They're new, fresh sensors, ready to experience flavor as if for the first time. It makes you wonder if taste changes slightly with each regeneration, if the strawberry you eat today tastes fractionally different from the one you ate last month. Not because the strawberry changed, but because you did. Your body is perpetually new, even in the smallest details. Humans can hear sounds ranging from 20 hertz to 20,000 hertz, a range that covers everything from the lowest rumble of thunder to the highest whistle you can imagine. But we lose the ability to hear higher frequencies as we age. The delicate hair cells in your inner ear, which vibrate in response to sound waves, gradually wear out and die. They don't regenerate. Once they're gone, and with them goes a slice of the audible spectrum. Many sounds that filled your childhood have gradually faded into silence. The highest notes, the frequencies that only young ears can detect, have slipped away so gradually you probably didn't notice. It's a gentle kind of loss, this erosion of hearing. But it's also a reminder that experience has a cost. Every sound you've ever heard has been processed by those hair cells, and each vibration wears them down just a tiny bit. You're trading hearing range for the accumulated experience of a lifetime of sound. By the time you're old, you'll have heard so much, but you'll hear a narrower band of frequencies. It's the price of living, written in the architecture of your ears. Your eyes can detect a single photon of light, the smallest possible unit of light that exists, though your brain needs about 5 to 7 photons arriving simultaneously to register the sensation consciously. The fact remains, your eyes are sensitive enough to respond to the absolute minimum of visible light. This makes your eyes among the most sensitive light detectors in nature, capable of functioning across an enormous range of brightness, from starlight to sunlight. Think about what that means. You're equipped to perceive the faintest glimmers of light across vast distances, to see the light from stars that traveled for years or centuries to reach you. Your eyes are cosmic instruments, built to capture photons that have journeyed across space and time. When you look up at the night sky and see a distant star, you're not just looking at light. You're catching particles that began their journey before you were born, maybe before your parents were born. Your eyes are time machines of a sort, letting you see into the past with every glance at the heavens. The human eye moves in incredibly precise ways, making about 3 to 4 tiny movements per second, called microsaccades. These movements are so small, you're completely unaware of them, but they're essential for vision. Without these constant, trembling adjustments, your vision would fade into a gray blur within seconds. Your visual system needs change, needs movement to function. If an image stays perfectly still on your retina, your brain stops processing it, assumes it's not important. So even when you think you're staring steadily at something, your eyes are dancing, vibrating, constantly refreshing the image on your retina. You never see anything in perfect stillness. You're always moving, always adjusting, always in flux. It's a good metaphor for consciousness itself, maybe. You feel still, feel like a stable observer looking out at the world, but really you're in constant motion, constantly recalibrating, constantly changing your perspective, even when you think you're standing still. Stillness, it turns out, is an illusion maintained by motion too small to notice. Your sense of taste is 75% smell. The flavors you experience when you eat aren't just coming from your tongue. They're coming from your nose, from the volatile compounds that drift up through the back of your throat and into your nasal cavity. This is why food tastes bland when you have a cold. Your taste buds are working fine, but your sense of smell is blocked. And without it, you're left with only the basic sensations of sweet, salty, sour, bitter, and umami. Everything else, the complexity, the richness, the specific character of flavor, comes from smell. What we think of as flavor is actually a collaboration between multiple senses. Your brain takes the input from your taste buds, combines it with the information from your olfactory receptors, adds in the texture and temperature from your mouth's touch receptors, and somehow synthesizes all of that into the unified experience of eating. You're not tasting with your tongue alone. You're tasting with your whole face, with a network of sensors that work together to create something richer than any one of them could achieve alone. Eating is a symphony, not a solo. Humans have a sixth sense called proprioception, the awareness of where your body parts are in space without looking. Close your eyes right now. You still know where your hands are, don't you? You can touch your nose, wave your arms, move your feet, all without visual confirmation. That's proprioception, an internal map of your body that updates constantly based on signals from your muscles, joints, and tendons. It's so automatic, so fundamental to how you move through the world, that you probably never think about it. But without proprioception, even simple tasks would become nearly impossible. You'd have to watch your feet to walk, watch your hands to pick up a cup, constantly monitor your body visually to know what it's doing. People who lose proprioception through injury or illness describe it as feeling like they're piloting a body remotely, like there's a disconnect between their sense of self and their physical form. It's proprioception that makes your body feel like yours, that creates the seamless integration between intention and movement. You think about reaching for something, and your hand just goes there. That's proprioception, working invisibly, perfectly, almost all the time. The nerve that connects your eye to your brain, the optic nerve, transmits data at roughly 10 million bits per second. That's faster than most internet connections, all happening inside your head without any conscious effort on your part. Every moment you're awake, your eyes are capturing an enormous amount of information and sending it racing back to your visual cortex, where it's processed into the seamless experience of sight. 10 million bits per second. It's hard to even comprehend that much information flowing through a single nerve, and yet it's happening right now as you read this. Your brain is receiving a constant, high-speed stream of visual data, parsing it, making sense of it, constructing the stable world you see around you. And that's just vision. Add in hearing, touch, smell, taste, proprioception, and you begin to realize just how much processing power your brain is dedicating to the simple act of being aware of your surroundings. You are, at every moment, an information processing system of staggering complexity running on 20 watts of power. Your retinas actually detect images upside down, but your brain automatically flips them right side up. The way lenses work, including the lens in your eye, they invert the image. So the light coming from the floor hits the top of your retina, and the light from the ceiling hits the bottom. But you don't see an inverted world. You see everything right side up because your brain corrects for this inversion before you're consciously aware of it. You've been seeing an inverted world that your brain flips for you, and you never knew. It happens so early in the processing chain that it never even reaches your conscious awareness. There are experiments where people wear special glasses that invert their vision, and after a few days, their brains adapt. They start seeing normally again, even though the world is technically upside down on their retinas. And then when they take the glasses off, everything looks upside down for a while until their brain readapts. Your sense of up and down is more flexible than you'd think, more dependent on interpretation than on raw sensory data. Humans can distinguish between thousands of different pain types: burning, aching, stabbing, throbbing, sharp, dull, tingling, pressing. Pain is not just one sensation, but a complex language your body uses to communicate damage or danger. Different types of pain travel through different nerve pathways, arrive at different speeds, signal different kinds of problems. A sharp, sudden pain tells you something different than a slow, deep ache. Pain is your body's alarm system, its way of getting your attention when something is wrong. It's unpleasant by design. It has to be, or you wouldn't pay attention to it. But it's also information, a detailed report about what's happening in your tissues, your organs, your nervous system. The specificity of pain, the way you can tell burning from freezing from crushing, is a testament to how sophisticated your sensory system is. Pain is terrible to experience, but it's also a gift in a way. A warning system that has kept your ancestors alive long enough to become your ancestors. The human nose can detect certain substances at concentrations as low as 1 part per trillion. That's like detecting a single drop of water in an Olympic swimming pool filled with liquid. For some compounds, particularly those that signal danger, like the smell of gas or smoke, your nose is incredibly, almost impossibly sensitive. You can smell things that laboratory instruments struggle to detect, all because of the molecular receptors in your nasal cavity that have been fine-tuned by millions of years of evolution. This sensitivity served a crucial purpose for your ancestors. Being able to smell spoiled food, smoke from a distant fire, predators lurking nearby, these abilities meant the difference between survival and death. Your nose is an early warning system, a detector of threats and opportunities that works even when you're not consciously paying attention. Even now, walking through the world, your nose is constantly sampling the air, checking for anything unusual or important. Most of the time you ignore it, but it's always there, always monitoring, always ready to alert you if something important drifts by on the breeze. Your body has more bacterial cells than human cells. The ratio is roughly 1.3 bacteria to every human cell. That means for every cell that's genetically you, there's more than one cell that belongs to a completely different organism. These bacteria live on your skin, in your mouth, throughout your digestive tract. They're not invaders. They're residents, partners, essential collaborators in the project of keeping you alive. Without them, you couldn't digest certain foods, synthesize certain vitamins, or maintain a healthy immune system. You are, in a very real sense, a walking ecosystem more than an individual organism. The boundary between you and not you is blurrier than you might think. These bacteria have their own DNA, their own life cycles, their own evolutionary imperatives, and yet they're part of you, living in and on your body, contributing to your health and well-being. You're not a single being, but a collective, a community of trillions of organisms working together. When you say I, you're speaking for a multitude that you'll never see, never consciously control, but can't live without. Each cell in your body contains about 6 feet of DNA, but it's wound so tightly it fits inside a nucleus that's only 0.002 inches wide. It's an extraordinary feat of molecular origami, this packing job. The DNA double helix is wrapped around proteins called histones, which are bundled together into chromatin, which is further compressed into chromosomes. Layer after layer of organization, each one more compact than the last, until you have this enormous length of genetic information compressed into something you can't see without a microscope. If you unraveled all the DNA in your body, all 37 trillion cells worth, it would stretch from Earth to Pluto and back. 17 billion miles of genetic code, all of it packed inside you, fitting comfortably inside a body you can wrap your arms around. It's hard to comprehend that kind of information density, that kind of miniaturization. Every instruction for building and maintaining you, every gene you inherited from your parents, all of it coiled up in spaces so small you can barely imagine them. You're carrying a library of unimaginable size, written in a language of 4 chemical letters, stored in every cell. Red blood cells live for about 120 days, while white blood cells might last only a few days, or, for some types, several years. Your blood is in constant flux, with millions of cells dying and being born every second. Right now, as you're reading this, old red blood cells are being broken down in your spleen and liver, their components recycled, while new ones are being manufactured in your bone marrow. It's a perpetual cycle of death and renewal, invisible and automatic. The blood flowing through your veins today isn't the same blood that was there 4 months ago. It's been completely replaced, cell by cell, in a gradual turnover that you never feel. And yet it performs the same functions, carries the same oxygen, fights the same infections. The substance changes, but the pattern remains. It's another example of how you're not a fixed thing, but a process, a constant becoming rather than a static being. The you of 4 months ago had different blood, different skin, different stomach lining, but you're still you. What persists isn't the material but the organization, the pattern that material takes. Nerve cells can be up to 3 feet long in tall people, stretching from the base of your spine all the way to your toes. These are among the longest cells in nature, spanning nearly the full length of the body. Imagine a single cell, one continuous structure, running from your lower back to your foot. It's an engineering marvel, this ability to maintain a functional cell across such distances, to keep signals flowing smoothly across 3 feet of cellular machinery. These long neurons are part of why you can feel your toes, why you can wiggle them on command, why you know when you've stepped on something sharp. They're communication lines, connecting your brain and spinal cord to the far reaches of your body. And when they work properly, the signal travels so fast, 250 miles per hour, remember, that the distance barely matters. You don't notice any lag between deciding to move your toe and feeling it move. But that signal is racing through one of the longest cells you have, covering what for a cell is an almost incomprehensible distance. Your liver is the only internal organ that can completely regenerate from as little as 25% of its original mass. If you somehow lost 3/4 of your liver, the remaining quarter could grow back, rebuilding itself into a full-sized, fully functional organ. It's one of the closest things to a superpower that humans naturally possess, this ability to regrow an entire organ from a fraction of its original tissue. The liver does this through a process where mature liver cells, which normally don't divide, suddenly start dividing rapidly, creating new tissue to replace what was lost. It's as if the liver knows how big it's supposed to be and keeps growing until it reaches that size, then stops. Scientists still don't fully understand all the signals and mechanisms that control this process, but they know it works reliably and remarkably. If you were to donate part of your liver to save someone's life, your liver would grow back, and the recipient's partial liver would also grow to full size. 2 complete organs from one. It's the kind of thing that seems like it should be science fiction, but it's just biology working quietly inside you. Mitochondria, the powerhouses of your cells, have their own DNA separate from your main genome. This DNA is inherited only from your mother. Your father's mitochondria, which are in the tail of the sperm, don't make it into the egg during fertilization. So the mitochondria in every cell of your body came from your mother, and hers came from her mother, in an unbroken chain stretching back through time. These organelles are believed to be ancient bacteria that merged with our ancestors billions of years ago, forming a partnership that became permanent. They gave up their independence in exchange for a stable environment and steady supply of nutrients, and in return, they generate the energy that powers your cells. It's one of the most successful collaborations in evolutionary history, this fusion of 2 separate organisms into one. You're not just a human, you're a human carrying billions of modified bacteria, creatures that became so integrated into your cells that you can't survive without them. Life is built on partnerships like this, on ancient agreements that have long since become invisible. Your body produces about 25 million new cells every second, even while you sleep. 25 million every second. It's a pace of creation that's hard to fathom, a rate of production that never stops, never slows down significantly. Right now, in your bone marrow, your skin, your intestines, your liver, cells are dividing, differentiating, taking their places in the grand architecture of your body. Life is not a state of being, but a continuous process of creation and renewal. You're not a finished product, something that was assembled and now just exists. You're always under construction, always being rebuilt, cell by cell, moment by moment. The work of being alive is constant, invisible, happening at scales too small to see and too fast to track. But it's there, this ceaseless activity, this perpetual renovation. You are always becoming yourself, never quite arriving at a final form, always in motion even when you're standing still. Some cells in your body, like certain neurons and heart muscle cells, last your entire lifetime without being replaced. They're born when you are, or shortly after, and they stay with you until you die. Parts of you are exactly as old as you are, bearing witness to every moment you've lived. These cells have been there for everything, every joy, every sorrow, every ordinary Tuesday afternoon. They're a kind of continuous thread running through your life, unchanging amid all the change. It's strange to think about, isn't it? That some pieces of you are as ancient as your earliest memories, that they've been working this whole time without rest or replacement. Your heart has been beating with the same muscle cells since childhood, pumping blood through your body for decades without ever taking a break. Some neurons in your brain have been firing since you first learned to think, storing memories that span your entire conscious existence. These cells are you in the most literal sense. They're the only parts of you that have been present for the entire story. Your cells communicate using thousands of different chemical signals, creating a conversation more complex than any language. Hormones, neurotransmitters, cytokines, growth factors. These molecules carry messages from one cell to another, coordinating activities across vast distances in cellular terms. A cell in your pancreas can send a signal that affects cells in your muscles, your liver, your brain. It's a network of communication happening constantly, invisibly, at every moment. This chemical chatter coordinates everything from your heartbeat to your mood. When you feel happy, that's partly because cells in your brain are releasing serotonin and dopamine, which bind to receptors on other neurons, changing their activity. When you eat, cells in your stomach release hormones that tell your brain you're full. When you're stressed, your adrenal glands release cortisol, which affects cells throughout your body. You're not hearing this conversation, not consciously aware of it, but it's happening all the time, in every part of you. A symphony of signals that creates the experience of being alive. Cancer cells can theoretically live forever if given nutrients, unlike normal cells which have a programmed death. Normal cells can only divide a certain number of times before they reach what's called the Hayflick limit and stop dividing. But cancer cells bypass this limit, gaining the ability to divide indefinitely. The oldest living cells from a human are from 1951. They're called HeLa cells, taken from a woman named Henrietta Lacks, who died of cervical cancer. Those cells are still dividing in laboratories worldwide, more than 70 years later. It's an unsettling kind of immortality, this ability of cancer cells to outlive the person they came from. Henrietta Lacks has been dead for decades, but her cells continue to live, continue to divide, contributing to countless medical research projects. They've been to space, been used in developing vaccines, helped advance our understanding of countless diseases. There are more of her cells alive now than when she was living. It raises strange questions about where life ends and what it means for a part of someone to keep existing long after the whole is gone. In a way, pieces of her are still here, still working, still contributing, even though she never knew and never benefited from it. your brain generates about 12 to 25 watts of electricity, enough to power a low-wattage LED bulb. Every thought you have is literally electric, a storm of charged particles dancing between neurons. When you remember something, when you feel an emotion, when you solve a problem, you're creating patterns of electrical activity that ripple through your brain like waves across water. These waves can be measured with an EEG, electrodes on your scalp, detecting the faint electrical signature of your consciousness. It's remarkable, really, that thinking requires electricity. Your brain is an electrical organ, running on the same fundamental force that powers your lights and computer, but it's far more efficient than any computer we've built. 25 watts, that's less power than most laptops use, and yet your brain can do things no computer can match. It can recognize faces instantly, understand ambiguous language, feel love and fear and wonder, create art and music and mathematics. All of that on the power consumption of a dim light bulb. Every time you have a thought, you're literally lighting up, generating a small spark of electricity. That is, in that moment, the physical form of your consciousness. The brain has no pain receptors, which is why surgeons can operate on it while patients are awake. You can have your skull opened, electrodes placed on your brain tissue, parts of your brain stimulated or removed, and you won't feel pain from the brain itself. You'll feel the scalp being cut, the pressure on your skull, but the brain tissue itself is numb to pain. The organ that processes all your suffering cannot feel its own suffering. It's a strange irony, almost poetic in its contradiction. This is why some brain surgeries are done with the patient conscious, talking to surgeons, so doctors can map which areas control speech or movement and avoid damaging them. Imagine that, being awake while someone operates on your brain, feeling completely aware and alert while your skull is open and your thoughts are, in a sense, exposed. The brain can observe itself being altered, can remain conscious while being touched and modified. It's one of the most surreal aspects of neurosurgery, this ability to work on the organ of consciousness while consciousness itself remains intact and aware. Your brain continues to develop and change until you're about 25 years old, particularly the prefrontal cortex responsible for decision-making, impulse control, and long-term planning. The you of your teenage years is neurologically incomplete, still under construction. The parts of your brain that help you assess risk, consider consequences, and regulate emotions aren't fully mature yet. This isn't an excuse exactly, but it is an explanation for why adolescence can be such a turbulent time. You're not just learning during those years. You're literally building the neural architecture that will carry you through adulthood. Every decision you make, every habit you form, every experience you have is shaping your brain at a time when it's still highly plastic, still capable of dramatic change. By your mid-20s, your brain has largely settled into its adult configuration. It can still change, still learn and adapt, but the pace of structural change slows down. You become more yourself, more fixed in your patterns. The foundation is set, for better or worse, by the life you've lived up to that point. Memories aren't stored in one place, but distributed across different regions of the brain, reassembled each time you recall them. When you remember something, your brain is actively reconstructing that memory from scattered pieces. Visual information from your visual cortex, emotional content from your amygdala, contextual details from your hippocampus. It's more like improvising from a script than playing back a recording. And every time you remember something, you change it slightly, introducing small distortions, updating it with new information or current emotions. Every memory is a recreation, not a recording, which is why they can change over time. You might remember an event one way now and a slightly different way in 10 years. You're not lying. You're just remembering your last memory of the event, which has been subtly altered from the original. Memories are living things, evolving entities that shift and mutate with each recall. The past you think you remember is partly fiction, a story you've told yourself so many times it feels true. And in a sense, it is true. It's your truth, the version of events that your brain has constructed from fragments and feelings, and the person you are now. Your brain uses sleep to flush out toxic proteins that accumulate during waking hours, including beta amyloid proteins linked to Alzheimer's disease. During deep sleep, the space between your brain cells actually expands, and cerebrospinal fluid flows through these spaces like a tide, washing away metabolic waste. It's called the glymphatic system, discovered only in the last decade or so, and it explains part of why sleep is so essential. Your brain isn't just resting during sleep, it's cleaning itself. Sleep is your brain's maintenance cycle, as essential as the thinking you do while awake. Without it, toxins build up, neurons become less efficient, connections weaken. This is why sleep deprivation makes you feel foggy and slow. Your brain is literally dirty, clogged with waste products that should have been cleared away. Every night you sleep, you're giving your brain the chance to reset, to clear out the debris of the day's thinking, to prepare for tomorrow. It's not laziness. It's necessary maintenance, as important as any task you do while awake. The human brain can process images in as little as 13 milliseconds, faster than the blink of an eye. You understand what you're seeing before you're consciously aware of looking. Your visual system is incredibly fast, extracting meaning from patterns of light and shadow almost instantaneously. By the time you consciously register an image, your brain has already done substantial processing, already identified objects and faces and potential threats, already begun preparing responses. Much of vision happens below the level of consciousness. You see things you don't know you've seen, process information you're not aware of processing. Your brain is making decisions based on visual input before you consciously experience looking. This is why you can sometimes feel like something is wrong before you know what it is, why you can sense danger before you've identified the threat. Your visual system is ahead of you, always scanning, always analyzing, feeding you the results of its processing in the form of intuitions and feelings that seem to come from nowhere. Your brain creates the perception of a continuous, stable visual world, but you're actually blind during the rapid eye movements called saccades. Several times per second, your eyes jump from one point to another, and during those jumps, you effectively can't see. But you never notice these gaps because your brain fills them in, creating a seamless experience of vision even though the input is actually choppy and interrupted. Your brain is constantly editing reality, smoothing out the rough patches, filling in the blind spots, making sure your experience of the world feels continuous and stable. You think you're seeing reality directly, but really you're seeing a reconstruction, a simulation your brain creates based on sensory input and expectations and memory. The world you experience is partly invented, partly real, a collaboration between what's actually out there and what your brain expects to find. You're not watching reality unfold. You're watching your brain's best guess about what's happening. Chronic stress can physically shrink the hippocampus, the brain region responsible for memory and learning. Prolonged exposure to stress hormones like cortisol can damage neurons in the hippocampus, causing it to lose volume, to become smaller. This isn't just metaphorical. Stress doesn't just make you feel bad. It physically changes the structure of your brain. And a smaller hippocampus means more difficulty forming new memories, more trouble learning new information, sometimes even problems accessing old memories. Your experiences don't just change how your brain works, they change its physical structure. Trauma, chronic stress, prolonged unhappiness. These don't just affect your mood, they reshape your brain, altering the very organ that creates your experience of being alive. The good news is that the hippocampus can recover, can regain volume if the stress is removed. The brain is plastic, capable of healing, capable of growing new connections even in adulthood. But it's a reminder that taking care of your mental health isn't separate from taking care of your physical health. Your mind and brain are one thing, and what hurts, one hurts the other. The brain's left and right hemispheres are connected by about 200 million nerve fibers called the corpus callosum. These fibers transfer information between hemispheres at speeds up to 200 miles per hour, keeping both sides of your brain in constant communication. When you look at something, the information gets split. The left side of your visual field goes to your right hemisphere, and the right side goes to your left hemisphere. The corpus callosum integrates this information, so you experience a unified visual field instead of two separate halves. In rare cases, when people have severe epilepsy that can't be controlled with medication, surgeons sometimes cut the corpus callosum to prevent seizures from spreading between hemispheres. These split-brain patients appear mostly normal, but strange things happen in laboratory tests. Show them an image only to the right hemisphere, and they can't verbally describe it because language is usually in the left hemisphere. But they can draw it with their left hand, which is controlled by the right hemisphere. It's as if they have two separate consciousnesses, two separate minds sharing one body. The corpus callosum is what keeps you unified, what makes you feel like a single self instead of two separate entities. Phantom limb sensations occur because your brain has a map of your body that doesn't immediately update after amputation. In your somatosensory cortex, there's a region dedicated to each part of your body, a representation of your hand, your foot, your face, all laid out in a distorted map called the homunculus. When you lose a limb, that region of the brain doesn't just shut down. It's still there, still active, still expecting input that no longer comes. Sometimes it generates sensations on its own, phantom pain, phantom itching, the feeling that the missing limb is still there. Your sense of self extends beyond your physical boundaries, residing partly in neural patterns that represent your body rather than in the body itself. Some amputees feel like they can still move their missing limbs, can still feel them responding to their intentions. The limb is gone, but the idea of the limb, the neural representation, persists. It's a reminder that your body image, your sense of having arms and legs and a face, is a construct, a model your brain maintains. And sometimes the model outlasts the reality, leaving you feeling like you're more than you physically are. Your body operates on roughly a 24.2-hour internal clock, which is why we need sunlight to reset it each day. Without external cues, if you lived in a cave with no access to daylight, no clocks, no schedule, you would slowly drift out of sync with the actual day-night cycle. Each day would start a little bit later than the one before, your internal clock running just slightly slower than the rotation of the earth. Sunlight hitting your eyes in the morning is what synchronizes you, pulling your internal rhythm back into alignment with the outside world. This internal clock, your circadian rhythm, is controlled by a tiny cluster of about 20,000 neurons in your hypothalamus, called the suprachiasmatic nucleus. Despite being so small, this region orchestrates the timing of nearly every biological process in your body. When you feel sleepy, when your body temperature rises and falls, when certain hormones are released. You're a creature of rhythm, even when you're not aware of it, even when you're trying to stay up late or wake up early. Your body has its own sense of time, its own clock ticking away, trying to keep you synchronized with the spinning of the planet. Different organs have peak activity times. Your liver works hardest around 1 to 3 a.m., while your lungs peak around 3 to 5 a.m. Your kidneys, your heart, your digestive system, they all have times of day when they're most active, most efficient. Your body is conducting a silent symphony, each instrument playing loudest at its designated time. Traditional Chinese medicine has known this for thousands of years, organizing the day into 2-hour periods when different organs are thought to be at their strongest. Modern chronobiology is confirming what ancient medicine intuited, that your body doesn't function uniformly throughout the day. There are optimal times for eating, for exercising, for taking certain medications, for thinking clearly. Your body temperature peaks in the late afternoon, which is when your physical performance is typically best. Your immune system is more active at night, which is partly why you often feel worse at night when you're sick. You're not a machine that runs at constant speed. You're a collection of rhythms, waves of activity that rise and fall throughout the day, creating the complex pattern of being alive. Your sense of taste changes throughout the day, with sweet sensitivity peaking in the morning and salt sensitivity in the evening. This might explain why breakfast foods and dinner foods taste right at their respective times. A donut in the morning hits differently than a donut at midnight, not just culturally, but physiologically. Your taste receptors are responding to circadian signals, becoming more or less sensitive to different flavors based on the time of day. Even your preferences, your cravings, the foods that appeal to you, these might be partly driven by biological rhythms you're not consciously aware of. Your body knows what time it is, even if you don't look at a clock, and it adjusts your senses accordingly. In the evening, you might crave salty or savory foods because your taste buds are primed for them. In the morning, sweet things appeal because you're most sensitive to sweetness. You're not just choosing what to eat based on culture or habit. You're responding to internal signals, chemical tides that rise and fall with the hours, guiding you toward what your body thinks it needs at each moment. Humans naturally have 2 periods of sleepiness each day, one at night and a smaller dip in the early afternoon. The siesta isn't laziness, it's written into our biology. That post-lunch drowsiness, that heaviness that settles over you in the early afternoon. That's your circadian rhythm creating a window where sleep would come easily, where your body temperature drops slightly and your alertness naturally wanes. Different cultures have responded to this in different ways. Some embrace the afternoon nap, others push through it with caffeine and determination. But the rhythm is there regardless, ancient and persistent, suggesting that maybe our ancestors had a more flexible sleep pattern than we do now. Maybe they slept at night and napped in the afternoon, breaking their sleep into 2 chunks instead of trying to get it all at once. Modern life doesn't always accommodate this pattern, but your body still remembers it, still tries to follow it. Fighting against your own biology isn't easy. Sometimes it's worth listening to what your body is telling you, even if the world around you has other expectations. Your body temperature varies by about 1 to 2 degrees throughout the day, lowest around 4 to 6 a.m. and highest around 4 to 6 p.m. You are quite literally a different temperature of person at dawn than at dusk. This variation is part of your circadian rhythm, controlled by the same internal clock that regulates your sleep and wakefulness. Your temperature drops at night to facilitate sleep. Lower body temperature is one of the signals that tells your brain it's time to rest. This is why a hot bath before bed can help you sleep. It raises your body temperature temporarily, and then when you get out, your temperature drops rapidly, mimicking the natural decline that happens at bedtime. Your body interprets this drop as a signal to sleep. Temperature is intimately connected to consciousness, to alertness, to how awake or drowsy you feel. When you're sick and running a fever, it's not just that you feel hot. Your whole sense of being is altered because your temperature regulation system is disrupted. You're not separate from your body temperature. You are, in part, your body temperature, rising and falling in a daily rhythm as reliable as the tide. Hair and nails grow faster in summer than in winter, responding to seasonal changes even in climate-controlled environments. You might never go outside, might live your entire life in artificially lit rooms at constant temperature, and still your hair would grow faster when it's summer outside. Ancient rhythms persist even when we've removed ourselves from natural cycles. Your body still knows what season it is, somehow, through mechanisms we don't fully understand. Maybe through subtle changes in daylight duration that your eyes detect. Maybe through other cues we haven't identified yet. Evolution shaped you for a world without walls, without electric lights, without thermostats. You carry the legacy of that world in your cells, in rhythms and patterns that made sense for creatures living directly in nature. Now we've built an artificial environment, a buffer between ourselves and the natural world, but we can't quite escape the patterns bred into us over millions of years. Your body is still trying to be seasonal, still responding to summer and winter, even if those seasons barely affect your daily life anymore. Your immune system follows a circadian rhythm, with inflammatory responses strongest in the morning. This is why vaccines given in the morning often produce stronger immune responses. Your immune system is more active, more ready to respond earlier in the day. It's also why you tend to feel worse in the morning when you're sick. Your body is ramping up its defenses, increasing inflammation to fight off infection, and you feel that as fever, aches, fatigue. Even your body's defenses follow a schedule, operating on a clock you don't consciously control. There are optimal times for your immune system to be vigilant, times when it's more likely to encounter threats based on the behavior patterns of your ancestors, active during the day, exposed to potential infections, needing robust defenses. At night, when they slept relatively safely, the immune system could afford to dial back a bit. Your immune cells are smarter than you'd think, coordinating their activities not just with each other, but with the time of day, maximizing their effectiveness while minimizing the cost to your body. The lining of your intestines completely replaces itself every 3 to 5 days, one of the fastest regeneration rates in the body. Your digestive system is perpetually new, constantly rebuilding itself from the inside. This makes sense when you think about what your intestines do. They're in contact with everything you eat, including substances that might be toxic or abrasive. They take a beating. These delicate surfaces responsible for absorbing nutrients while keeping harmful bacteria and toxins from entering your bloodstream. So they renew themselves constantly, shedding old cells and growing new ones at a pace that's almost hard to believe. Every few days, you have what is essentially a new digestive tract. The you that ate breakfast Monday and the you that eats breakfast Friday have different intestinal linings. Same person, different cells. It's another reminder of how dynamic you are, how much of your body is in constant flux. The parts that seem most stable, most solid, are actually turning over all the time, dying and being reborn in cycles you never feel. Human reaction times are fastest in the late afternoon, around 4 to 6 p.m., when body temperature peaks. Athletes who compete at this time may have a slight biological advantage. Their reflexes are sharper, their coordination is better, their muscles respond more quickly. Olympic records, world records in various sports, tend to be set in the late afternoon or early evening, when the body is at its physiological peak for physical performance. Your abilities aren't constant throughout the day. You're better at different things at different times, not just because you're more or less tired, but because your biology changes hour by hour. Early morning might be good for creative thinking, when your mind is fresh and less constrained by the day's experiences. Late afternoon is good for physical tasks, for reactions, for anything that requires quick responses. Evening might be better for strategic thinking, for integrating information, for seeing patterns. You cycle through different versions of yourself throughout the day, each one slightly better suited to certain kinds of tasks. Your pupils naturally dilate and constrict in a rhythm called hippus, even in unchanging light conditions. If you watch someone's eyes closely, or your own in a mirror, you can sometimes see this, a slight pulsing, a gentle oscillation in pupil size. It's not responding to changes in light, it's just happening, a rhythm your eyes maintain for reasons that aren't entirely clear. Maybe it's helping to optimize vision, to keep the photoreceptors in your retina responsive. Maybe it's adjusting for tiny changes in where you're focusing. Or maybe it's just a side effect of the neural circuits that control pupil size, a small fluctuation in the system. This constant micro-adjustment, this trembling at the edges of your vision, is happening all the time without you noticing. Your body is never truly still, never truly static. Even when you think you're doing nothing, holding perfectly steady, your body is making tiny adjustments. Your eyes are moving in microsaccades. Your pupils are fluctuating in hippus. Your muscles are making microscopic contractions to keep you balanced. Stillness is an illusion maintained by constant motion too small to perceive. You are always in flux, always adjusting, always dancing in place even when you think you're standing still. Scientists discovered in 2015 that the brain has a lymphatic system previously thought not to exist, changing our understanding of neurological diseases. For over a century, textbooks taught that the brain had no lymphatic vessels, no way to drain waste the way the rest of the body does. But it turns out we were wrong. There are lymphatic vessels in the meninges, the membranes surrounding the brain, and they play a crucial role in clearing waste products and immune cells from the central nervous system. We're still finding new organ systems in a body we thought we'd completely mapped. Despite centuries of studying human anatomy, despite millions of dissections and countless medical textbooks, we missed something fundamental about how the brain maintains itself. It makes you wonder what else we might be missing, what other systems might be hiding in plain sight, waiting for the right tools or the right questions to reveal them. The human body is not fully known. It's still full of mysteries, still capable of surprising us, even after all this time spent trying to understand it. Your gut microbiome produces about 90% of your body's serotonin, the neurotransmitter associated with mood and happiness. Think about that for a moment. The bacteria in your intestines are manufacturing most of the chemical that influences whether you feel happy or sad, anxious or calm. Your mental state may be more influenced by your digestive system than previously imagined, more dependent on the trillions of microorganisms living in your gut than on anything happening in your brain alone. This is part of what's called the gut-brain axis, a constant two-way communication between your digestive system and your central nervous system. The bacteria in your gut send signals to your brain through the vagus nerve, through immune messengers, through the hormones and neurotransmitters they produce. And your brain sends signals back, influencing what bacteria thrive and what kind of environment exists in your gut. You're not just feeding yourself when you eat, you're feeding an ecosystem, and that ecosystem is affecting your thoughts, your emotions, your sense of well-being, depression, anxiety, even some aspects of personality might be partly microbial, partly a product of the bacterial community you're hosting. Recent research shows that the heart contains about 40,000 neurons, a little brain that can sense, learn, and remember independently of the brain in your head. Your heart isn't just a pump, not just a mechanical device pushing blood through your circulatory system. It's an intelligent organ with its own nervous system, capable of processing information and making decisions without input from your brain. In fact, the heart sends more signals to the brain than the brain sends to the heart, suggesting that the heart might have more influence over your mental state than we traditionally thought. This might explain why heart transplant recipients sometimes report changes in personality, preferences, even memories that seem to belong to the donor. It's controversial, and many scientists are skeptical. But there are enough documented cases to make you wonder. What if the heart stores information, holds some aspect of identity? What if when people say they know something in their heart, they're not being purely metaphorical? Your heart is not just feeling the emotions your brain generates. It might be participating in creating them, contributing its own signals to the complex experience of being you. Scientists can now grow tiny organoids, miniature organs grown from stem cells, including mini brains that show electrical activity. These aren't full brains, not conscious entities, but they're organized clusters of neurons that fire in coordinated patterns, that respond to stimuli, that display some of the basic properties of actual brain tissue. Researchers use them to study development, to test drugs, to understand diseases. But they also raise profound questions about what consciousness is, when it begins, whether these tiny clusters of cells might have some rudimentary form of experience. These lab-grown structures blur the line between biological study and creation. We're not just observing life anymore. We're making it, assembling it from components, growing pieces of bodies in dishes. It's extraordinary science, potentially revolutionary for medicine and research, but it's also unsettling in a way that's hard to articulate. When does a cluster of neurons become something that deserves moral consideration? At what point does organization become experience? We're venturing into territory where the questions are as important as the answers, where the technology is moving faster than our ethics can keep up. The interstitium, discovered in 2018, is a network of fluid-filled spaces throughout the body that may be one of our largest organ systems. It's not a single organ, but a previously unrecognized structure. Spaces between tissues, filled with fluid, interconnected throughout your body. For years, scientists thought these spaces were just artifacts of how tissue samples were, prepared for microscopy. But they're real, they're functional, and they might play important roles in how tissues move, how cancer spreads, how fluids circulate through your body. Major anatomical features can still hide in plain sight within the human body. We've been looking at these spaces for over a century without recognizing what they were, without understanding their significance. The interstitium might be one of the largest organs in your body, and we only just noticed it. It's humbling, really, this reminder that we don't know ourselves as completely as we think. Your body is still revealing secrets, still showing us features we overlooked, still surprising us with its complexity. Your cells contain jumping genes, called transposons, that can copy themselves and move around your genome, potentially affecting brain function. These mobile genetic elements, sometimes called selfish DNA, make up nearly half of your genome. They can insert themselves into new locations, potentially disrupting genes or changing how they're regulated. For a long time, scientists thought they were mostly dormant in humans, evolutionary relics that no longer did much. But recent research suggests they're active in the brain, particularly in neurons, where they might contribute to the diversity of brain cells, and possibly even to memory formation. Your DNA is not fixed, but dynamic, with elements that rearrange themselves throughout your life. Every time a transposon jumps, it creates a cell that's genetically different from its neighbors, adding another layer of individuality to your already unique genome. This might be part of why every neuron in your brain is slightly different. why your brain is not just a product of the genome you inherited, but also of random events that happen during development and continue happening throughout your life. You're more than your genetic blueprint. You're the blueprint plus all the accidents, all the random insertions and deletions, all the chaos that makes you specifically you. Recent studies show that the appendix may have evolved independently at least 30 times across different species, suggesting an important function. When a structure evolves multiple times independently, it usually means it's solving an important problem, providing some significant advantage. The appendix keeps showing up in evolution, which suggests it's doing something valuable. As we discussed earlier, it might be a safe house for beneficial gut bacteria, a reservoir that helps repopulate your intestines after illness. What we dismissed as vestigial may be more valuable than we realized. It's a pattern in science. We assume that if we don't understand something's purpose, it must not have one. We're quick to label things useless, to assume that what we can't explain must be evolutionary baggage. But nature is rarely wasteful over long time scales. If something persists, if it keeps reappearing across different lineages, there's probably a reason. We just need to be patient enough, humble enough, to wait for the answer instead of assuming we already have it. Researchers discovered in 2020 that humans have a specialized sensor for detecting magnetic fields, though we don't consciously perceive it. The protein that allows this, cryptochrome, is found in your retinas and might be responding to Earth's magnetic field in ways that influence your biology, possibly even your navigation abilities. Birds use similar proteins to navigate during migration, sensing the planet's magnetic field to orient themselves. You might be doing something similar, subconsciously using magnetic information without knowing it. You may be navigating using Earth's magnetic field without realizing it, responding to a signal you can't consciously detect, but that influences your sense of direction nonetheless. Some researchers think this might explain why people sometimes have an intuitive sense of which direction is north, or why we sometimes feel disoriented in places where the magnetic field is disturbed. It's a sense we don't have a name for, one we're not taught about in school, but it might be there, working quietly, adding to the subtle information that shapes how you move through the world. The discovery of the glymphatic system showed that sleep position matters. Sleeping on your side may clear brain waste more efficiently than sleeping on your back or stomach. The channels that allow cerebrospinal fluid to flow through your brain and wash away toxins might work better when you're lying on your side. It's a small thing, maybe, but over decades it could make a difference in how effectively your brain clears out the proteins that accumulate during waking hours. Even the way you lie down affects your brain's health over decades. The position you sleep in, the angle of your head, these mundane details might have long-term consequences for cognitive health, for your risk of neurodegenerative diseases, for how well your brain ages. It's strange to think that something so simple, so arbitrary seeming, could matter. But your body is a system where everything connects to everything else, where small factors compound over time. The way you sleep tonight might affect how you think 20 years from now. It's the kind of thing that seems too small to matter, but maybe it does. Scientists found that a protein called prestin in your ear cells acts as a biological motor, amplifying sounds by actively vibrating. Your hearing isn't passive reception. It's an active, powered process. The cells in your cochlea don't just respond to sound waves. They move, they dance, they amplify the signal mechanically before sending it to your brain as electrical impulses. This is why your ears can detect sounds so faint, can distinguish between frequencies so similar. You're not just listening, you're participating, your ear cells working to enhance the sounds you hear. It takes energy to hear, just as it takes energy to see, to think, to feel. Nothing about perception is truly passive. You're always doing something, always expending effort, always working to construct your experience of the world. Hearing a whisper requires your ear cells to vibrate, to amplify, to translate mechanical waves into neural signals that your brain can interpret. The world doesn't just pour into you. You reach out and grasp it, actively, constantly, using biological machinery so sophisticated we're only beginning to understand how it works. The atoms in your body are 97% empty space. If you removed all the empty space, humanity could fit into a sugar cube. You are mostly nothing, held together by forces rather than substance. The electrons that orbit atomic nuclei are so far away, relatively speaking, that atoms are almost entirely void. The solid feeling of your body, the resistance when you touch something, that's not matter touching matter. It's electromagnetic forces repelling each other, fields pushing against fields. You feel solid, but you're mostly emptiness held in a particular pattern. The chair you're sitting on, the air you're breathing, the planet beneath you, all of it is almost entirely empty space. Matter is rare. What seems abundant, substance, solidity, the physical world, is actually a thin organization of almost nothing into patterns that feel like something. You are a pattern in the void, an arrangement of mostly empty atoms that somehow adds up to the experience of having weight, density, presence. Existence is stranger than it appears. Every atom in your body heavier than hydrogen was forged inside a star that exploded billions of years ago. The carbon, nitrogen, oxygen, calcium, iron, all of it was created in the cores of stars through nuclear fusion, then scattered across space when those stars died in supernovae. The universe began with just hydrogen and helium, the lightest elements. Everything else had to be manufactured, atom by atom, in stellar furnaces burning at millions of degrees. You are quite literally made of stardust, carrying the legacy of stellar death and rebirth in every cell. It's not a metaphor or poetry. It's physics, chemistry, the actual history of the atoms you're composed of. Those atoms are older than Earth, older than the sun, survivors of stellar catastrophes that happened before our solar system existed. They've been recycled through multiple generations of stars and planets, through countless organisms, through oceans and rocks and atmospheres. And now, for a brief moment in cosmic time, they're arranged in the pattern that is you, conscious and aware, able to contemplate their own origins. The calcium in your bones, the iron in your blood, and the carbon in your DNA were created in the cores of dying stars. Each element has its own story, its own stellar origin. The calcium came from massive stars that exploded as supernovae. The iron was forged in the final moments before such explosions, in the chaotic last seconds of a star's life. The carbon came from smaller stars in their red giant phase, puffing off their outer layers into space. You are an archive of cosmic history, each element telling a story of stellar alchemy. Your body is a collection of stellar deaths, a monument to the violent and beautiful processes that created the heavy elements necessary for life. Without stars dying, without the forge of nuclear fusion and the dispersal of supernova explosions, you couldn't exist. Life requires elements that can only be made in the most extreme conditions the universe offers. You are the universe's way of knowing itself, a temporary arrangement of stellar debris that has somehow achieved consciousness, awareness, the ability to look back at the stars and understand where you came from. Humans share about 60% of their DNA with bananas, 85% with mice, and 98.8% with chimpanzees. Life on Earth is one continuous family, variations on a shared genetic theme. The differences between you and a banana, profound as they seem, are written in a relatively small percentage of the genetic code. The fundamental machinery of life, how cells divide, how proteins are made, how energy is produced, is remarkably similar across all living things. You're related to everything alive, connected through an unbroken chain of inheritance stretching back billions of years to the first single-celled organisms. The bacteria in your gut, the trees outside your window, the birds flying overhead. You share a common ancestor with all of them, somewhere far back in time. Life is not diverse, separate creations, but one phenomenon, one experiment, endlessly elaborated and modified. You are part of this continuity, this family tree that encompasses every living thing. When you look at a tree or a bird or even a bacterium, you're looking at a distant cousin, something that shares your deepest biological heritage. The water in your body is over 4.5 billion years old, likely older than Earth itself, delivered by ancient comets. You're drinking the same water that dinosaurs drank, that filled ancient seas, that came from space. Water molecules are remarkably stable, surviving across eons, cycling through organisms and oceans and atmospheres, but remaining fundamentally the same. The hydrogen atoms in that water are even older. They were created in the Big Bang itself, in the first few minutes of the universe's existence. You are filled with the oldest substance in your body, water that has been everywhere, that has been part of countless other beings before becoming part of you. When you drink, you're consuming history, ingesting molecules that have witnessed the entire story of Earth and perhaps existed even before the planet formed. It's a strange intimacy, this sharing of water across time and species and worlds. Nothing is really yours. Everything is borrowed, temporarily arranged into the form of your body, eventually to be returned to the great circulation of matter and energy that connects all things. Every breath you take contains atoms that were once breathed by Leonardo da Vinci, Cleopatra, and every other person who ever lived. The atmosphere mixes thoroughly enough that molecules you inhale have been inhaled by countless others before you. You're breathing the same air as your ancestors, as historical figures, as strangers on the other side of the world. There's an invisible communion happening with every breath, a physical connection to all of humanity across time and space. The air connects all humans across time in an intimate, invisible network. You can't escape it, can't isolate yourself from this shared atmosphere. Every breath is a reminder that you're part of something larger, that the boundary between you and others is permeable, that we're all participating in the same cycles of matter and energy. It's humbling and beautiful at once. This idea that you carry traces of everyone who came before, that your exhalations will become part of everyone who comes after. We're all breathing each other all the time, in an exchange so fundamental we barely think about it. Your eyes can detect a candle flame from 30 miles away on a clear, dark night, about the sensitivity needed to see distant stars. Under ideal conditions, with no light pollution, your eyes can pick up a handful of photons from a tiny flame far beyond the horizon. You're equipped to perceive the faintest glimmers of light across vast distances, to detect signals that seem almost impossibly small and far away. This sensitivity is why you can see stars at all, why you can look up on a clear night and perceive lights that are trillions of miles away. Your eyes are cosmic instruments, refined by evolution to operate across an enormous range of light levels. They can function in bright sunlight, in the dim light of dawn, in the near darkness of a moonless night. And at the extreme edge of their sensitivity, they can see things so far away, so faint, that it seems impossible. You are built to perceive the universe, equipped with sensors sophisticated enough to detect the ancient light of distant stars. The odds of you existing with your exact genetic makeup are about 1 in 400 trillion. You're statistically impossible, yet here you are. Consider everything that had to happen for you to exist. Your specific sperm had to fertilize your specific egg out of millions of possibilities. Your parents had to meet. Their parents had to meet. Going back just a few generations, the number of things that had to happen exactly right becomes astronomical. Add in the survival of your ancestors through wars, famines, diseases, accidents across thousands of generations, and the probability of you specifically existing approaches 0. Your existence is the result of an unbroken chain of survival stretching back billions of years through mass extinctions and climate changes and countless dangers. Every single one of your ancestors lived long enough to reproduce, navigated all the hazards of existence, happened to meet the right person at the right time. You are the product of an almost infinite series of unlikely events, each one necessary, none of them guaranteed. You're a miracle of probability, a winning ticket in the universe's longest-running lottery. And yet here you are, improbable as you are, conscious and aware and real. Humans are one of the few species that can throw objects with deadly accuracy, thanks to unique shoulder anatomy that evolved for this purpose. Your shoulder is remarkably mobile, allowing your arm to rotate through a full circle, to wind up and release with tremendous speed and precision. This ability to throw, to project force at a distance with accuracy, may have been one of the key advantages that allowed early humans to survive and thrive. You could hunt without getting close to dangerous prey. You could defend yourself without direct contact with threats. This seemingly simple ability helped shape human evolution in profound ways. It required changes not just to the shoulder, but to the entire kinetic chain, the way your body transfers energy from your legs through your hips and torso and into your arm. It required sophisticated hand-eye coordination, spatial reasoning, timing. Throwing may have driven the development of larger brains, better motor control, more complex social behavior. Something as simple as throwing a rock became a defining human characteristic, one that distinguished us from other primates and potentially changed the trajectory of our species. Your body temperature is perfectly calibrated to the chemistry of Earth, just slightly below the boiling point that would denature proteins. Life operates in a narrow thermal window, and you live right at the optimal temperature for the chemical reactions that sustain you. Too cold, and reactions slow down. Metabolism grinds to a halt. Too hot, and proteins unfold, lose their structure, stop functioning. Your 98.6 degrees Fahrenheit is not arbitrary. It's a careful balance, a temperature where everything works just right. This is one of the many ways you're tuned to this planet, adapted to its conditions, built to function in this specific environment. You're not a universal being that could exist anywhere. You're an earthling, through and through, dependent on the temperature range, the atmospheric pressure, the gravitational field, the chemical composition of this particular world. You fit here because you evolved here, because your ancestors were shaped over millions of years to thrive in these conditions. You belong to Earth in a fundamental sense, not just culturally or emotionally, but physically, chemically, in the very temperature at which your proteins remain stable and functional. Scientists still don't fully understand why humans need to sleep, despite it consuming a third of our lives. Sleep is so vital that every known animal does it, risking vulnerability to predators, losing time that could be spent feeding or reproducing. And yet evolution has preserved this behavior across all of animal life, suggesting it's not optional, not a luxury, but absolutely essential. We know some of what sleep does. It clears waste from the brain, consolidates memories, regulates hormones, repairs tissues. But we don't know if any of these functions, or all of them combined, fully explain why sleep exists. The core purpose remains debated, mysterious, despite decades of research. Maybe sleep isn't for one thing, but for many things. A time when the body can perform maintenance tasks that can't happen while you're awake and active. Or maybe there's something fundamental we're still missing, some crucial function we haven't identified yet. You spend roughly 25 years of your life asleep, and we still can't say with certainty why you need to. It's one of the most basic aspects of being alive, and it remains, in important ways, a mystery. Perhaps that's fitting. Perhaps some things about existence are meant to remain a little bit unknown. Consciousness, the subjective experience of being you, remains one of neuroscience's greatest unsolved mysteries. We can map the brain in exquisite detail, can trace which neurons fire when you see red or feel sad or remember your childhood. But we can't explain how physical matter becomes aware of itself, how electrochemical signals in neurons transform into the felt experience of being conscious. There's what philosophers call an explanatory gap between the objective, measurable activity of the brain and the subjective, felt quality of experience. We can describe what happens when you're conscious, which brain regions activate, which neurotransmitters are released, which networks synchronize. But we can't explain why it feels like something to be you, why there's an inner experience at all. Some scientists think consciousness might be a fundamental property of the universe, like mass or charge. Others think it emerges from complexity, appearing when information processing reaches a certain threshold. Still others think we're asking the question wrong, that consciousness isn't a thing to be explained, but a process, a verb rather than a noun. Whatever it is, however it works, you have it. You are it. and that remains beautifully, incompletely understood. No one knows why humans are the only primates that cry emotional tears, or if those tears serve a biological function. Other animals produce tears to lubricate their eyes, to wash away irritants, but only humans seem to cry in response to emotions: sadness, joy, frustration, overwhelming beauty. Tears stream down our faces when we're moved, and we're the only species that does this. It might be a social signal, a way of communicating distress or need without words, or it might be a form of emotional regulation, a way of releasing stress hormones or resetting your nervous system. Crying may be uniquely human, but we don't truly understand what purpose it serves or why it evolved. It makes you vulnerable, visible, unable to hide what you're feeling. Maybe that's the point. Maybe tears evolved to create intimacy, to elicit care from others, to make emotional states visible in a way that builds social bonds. Or maybe they're just a byproduct of other systems, a side effect of having complex emotions and tear ducts in close proximity. Either way, you cry, and in crying you're doing something no other animal does, expressing your inner world in salt water that runs down your cheeks. The placebo effect can produce measurable physiological changes, but we don't fully understand how belief becomes biology. Give someone a sugar pill and tell them it's a powerful painkiller, and their brain releases endorphins, natural painkillers that actually reduce their suffering. The pain gets better not because of the pill, but because of the belief about the pill. Your mind can alter your body's chemistry through sheer expectation, a power we're only beginning to comprehend. It's not just in your head, it's in your brain chemistry, your immune response, your healing processes. Expectations change outcomes in ways that are real and measurable. Patients who believe they're receiving treatment often do better than those who don't, even when the treatment itself is inert. Your beliefs about your health affect your health, sometimes dramatically. This isn't wishful thinking or self-deception. It's a demonstration that the boundary between mind and body is more permeable than we assumed, that consciousness can reach down into physiology and alter it. The mystery is how. How does an abstract belief, an idea, translate into concrete biological change? We can observe it happening, but we can't fully explain the mechanism. We still don't know why humans have fingerprints. Theories include improved grip or enhanced touch sensitivity, but nothing is proven. These unique patterns that identify you, that mark you as distinct from every other human who has ever lived, may exist for reasons we haven't yet discovered. Maybe they channel moisture away from your fingertips to improve grip when handling objects. Maybe they amplify vibrations, making your sense of touch more sensitive, allowing you to feel textures more precisely. Or maybe they're just a developmental accident, a side effect of how skin forms in the womb, preserved because they're not harmful enough to be selected against. Your fingerprints are one of the most distinctive things about you, used to identify you, impossible to change or disguise, and yet we don't know why you have them. It's a reminder that even the most familiar features of your body can be mysteries, that the obvious questions don't always have obvious answers. You've had these patterns on your fingertips since before you were born, and they'll stay with you until you die. Unique markers of your existence whose purpose, if they have one, remains unknown. The mechanism behind general anesthesia, how it makes us unconscious, is still not completely understood despite over 170 years of use. We can reliably turn off consciousness with certain drugs, can make you unaware, unfeeling, absent from your body for hours at a time. But we don't fully know how these drugs work, why they block consciousness while leaving other brain functions relatively intact. We regularly turn off consciousness medically without fully knowing how the switch works. Anesthesiologists have refined their techniques through experience and observation, learning which drugs work and in what doses, even if the underlying mechanism remains partly mysterious. You can be rendered unconscious, can undergo surgery without any awareness or memory of it, can have your consciousness switched off and then switched back on, and the whole process rests on knowledge that's more empirical than theoretical. We're using tools we don't fully understand, manipulating consciousness in ways that work reliably, even though the explanation for why they work is incomplete. It's unsettling, maybe, but also remarkable that we can do something so profound with incomplete knowledge, that practical skill can outpace theoretical understanding. Scientists debate whether aging is an evolutionary adaptation or just accumulated damage, with profound implications for extending life. If aging is programmed into us, written into our genes as a feature rather than a bug, then maybe we can reprogram it, change the code, extend lifespan significantly or even indefinitely. But if aging is just damage accumulating, random mutations, protein degradation, cellular wear and tear, then slowing it might be much harder, requiring us to fix countless small problems rather than flipping one master switch. We don't know if death is programmed into us or just something that happens over time when systems aren't perfectly maintained. Some organisms don't seem to age. Certain jellyfish can revert to earlier life stages. Some trees live for thousands of years without showing signs of senescence. If aging isn't universal, if it's not an inevitable consequence of being alive, then maybe it's something we could change. Or maybe human aging is too deeply woven into our biology to untangle, too connected to other systems to modify safely. The debate continues, and the answer, when we find it, will shape how we think about life, death, and the time we have. The origin of left-handedness in 10% of humans remains mysterious, as does why this percentage is so consistent across cultures and time. Handedness seems to be at least partly genetic, but the inheritance pattern is complex and not fully understood. Left-handedness has persisted throughout human history, despite some cultural stigma against it, despite right-handed people having advantages in a right-handed world. Evolution has maintained this minority trait for reasons we still don't fully grasp. Maybe left-handedness provides some advantage in certain contexts. In combat, perhaps, where being left-handed makes you less predictable. Or maybe it's a side effect of how the brain divides labor between hemispheres, a quirk of cerebral lateralization that produces a consistent minority of left-handers as a natural consequence of brain organization. Whatever the reason, about 1 in 10 people throughout history has been left-handed, a stable minority that suggests there's something important about maintaining this variation. You might be part of that minority, or you might be part of the majority, but either way, the pattern persists across cultures and millennia for reasons evolution knows but hasn't fully revealed to us. We can't explain why humans experience subjective time differently, why some moments feel eternal while years can vanish. Time perception is one of consciousness's strangest properties, varying wildly without changing the actual clock. A boring afternoon can stretch into what feels like days. A joyful vacation disappears in what seems like hours. As you age, years seem to pass more quickly, each one a smaller fraction of your total life experience, each one less novel than the years that came before. Your brain is constructing your experience of time based on attention, memory formation, emotional state, novelty. When you're bored, you're paying attention to time itself, which makes it feel slower. When you're engaged, time passes unnoticed. When you're forming lots of new memories, time feels rich and full. When your days are routine and similar, time compresses, leaving fewer distinct markers for your memory to hold on to. But why subjective time works this way, why consciousness includes this flexible sense of duration that can expand and contract so dramatically, that remains mysterious. You live in time, move through it, but your experience of it is something your brain constructs, and we don't fully understand the rules of that construction. The question of where you really reside, in your brain, your body, your cells, or somewhere else entirely, remains philosophically and scientifically open. After everything we've learned about the human body, after mapping its systems and understanding its chemistry and watching it function at molecular scales, we still can't quite locate the self. Are you your brain? But your brain is constantly changing, and the neurons you have now aren't the ones you were born with, at least not exclusively. Are you your body? But your body is replacing itself continuously, shedding and rebuilding, cycling through materials. Maybe you're the pattern rather than the substance, the organization of matter rather than the matter itself. Maybe you're the process, the ongoing activity of being alive and conscious and changing. Or maybe you're something that emerges from complexity, a property that appears when systems reach a certain level of organization, like how wetness emerges from individual water molecules that aren't themselves wet. The location of the self remains beautifully, mysteriously undefined. You're here, experiencing this moment, undeniably present and aware. But where exactly here is, where the boundary of you begins and ends, that's a question that doesn't have a simple answer. And maybe that's okay. Maybe some mysteries are better left as mysteries, at least for now, at least for tonight. And so we've wandered through 100 facts about the human body, your body, the vehicle you've been traveling in since the moment you were born. We've looked at the electricity in your brain, the ancient rhythms in your cells, the stardust in your bones, the mysteries that remain even after centuries of study. You are more complex than you probably imagine, more mysterious than you might expect, more connected to the universe and to history and to other living things than you might consciously feel. You are, in the deepest sense, a process rather than a thing, a pattern of matter and energy that maintains itself, that repairs and rebuilds, that responds and adapts and changes while somehow remaining recognizably you. Your ancient atoms arranged in a temporary form, consciousness emerging from complexity, a small part of the universe that has become aware of itself and capable of wonder. As you drift towards sleep now, your body will continue its work. Your glymphatic system will flush toxins from your brain. Your cells will divide and die and be replaced. Your heart will beat about 400,000 more times before morning. Your immune system will patrol for threats. Your memories will be consolidated, sorted, integrated into the vast network of everything you know and have experienced. All of this will happen without your conscious awareness, without your effort, in the quiet hours while you dream. You are more remarkable than you probably give yourself credit for, carrying within you billions of years of history, trillions of cells working in harmony, systems within systems within systems, all coordinating to create the experience of being you. Rest well tonight, knowing that you are cared for by your own biology, watched over by processes older than humanity itself, part of something vast and ancient and ongoing. Thank you for spending this time with me tonight, exploring the quiet wonders of being human. Until next time, sleep well.